Current-carrying conductors are conductors that carry an electrical current. In an alternating current, or AC, system, the current flows in both directions, from the source to the load and back to the source. In a direct current, or DC, system, the current flows in one direction only. In a raceway or cable, the current-carrying conductors are the conductors that are connected to the electrical source and the load. Considering a situation with 8 conductors in a raceway, 4 hot and 4 neutral, where the voltage is 110 volts AC, the current-carrying conductors are the 4 hot conductors. The neutral conductor is not typically considered a current-carrying conductor for derating purposes because it is primarily used to provide a return path for the current under normal balance conditions. However, it is crucial to understand the nuances of neutral conductors in different circuit configurations. In a balanced 3-phase system, the neutral conductor ideally carries very little current. This is because the currents in the 3 phases are balanced and tend to cancel each other out in the neutral. However, if the system is unbalanced, meaning the loads on each phase are not equal, the neutral conductor will carry the difference in current. Additionally, in certain types of circuits, such as those with nonlinear loads like electronic devices, the neutral conductor can carry significant harmonic currents. These harmonic currents can cause the neutral conductor to overheat, even if the system appears to be balanced. Therefore, it's essential to consider the potential for harmonic currents when determining whether a neutral conductor should be counted as a current-carrying conductor for derating purposes. The National Electrical Code, or NEC, provides guidelines for determining when a neutral conductor should be counted as a current-carrying conductor. According to the NEC, a neutral conductor is considered a current-carrying conductor if it carries more than a negligible amount of current. This typically occurs in circuits with nonlinear loads or unbalanced 3-phase systems. If the neutral conductor is considered a current-carrying conductor, it must be included when calculating the derating factor for the conductors in the raceway or cable. Derating is the process of reducing the ampacity of conductors to account for the heat generated by multiple current-carrying conductors in close proximity. When multiple conductors are bundled together in a raceway or cable, the heat generated by each conductor can raise the overall temperature of the conductors. This increased temperature can reduce the ampacity of the conductors, potentially leading to overheating and insulation damage. The NEC requires that conductors be derated when there are more than 3 current-carrying conductors in a raceway or cable. The derating factor is determined based on the number of current-carrying conductors and the ambient temperature. Table 310.15. B tier. And the NEC provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These adjustment factors reduce the allowable ampacity of the conductors based on the number of current-carrying conductors. For example, if there are 4 to 6 current-carrying conductors in a raceway, the ampacity of each conductor must be reduced to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced to 70%. In the case of the 8 conductors, 4 hot and 4 neutral, the question arises whether to derate based on 4 or 8 conductors. Given that the neutral is only carrying current as a return path and assuming a balanced system with minimal harmonic distortion, only the 4 hot conductors are considered current-carrying for derating purposes. Therefore, referring to NEC Table 310.15. B2. AA. If there are 4 current-carrying conductors, the allowable ampacity of each conductor must be derated to 80% of its adjusted value. This means that if a conductor is rated for, let's say, 30 amps under normal conditions, it must be derated to 24 amps when installed in a raceway with 4 current-carrying conductors. It is important to note that the NEC provides exceptions to the derating requirements in certain situations. For example, if the conductors are installed in a raceway that is exposed to free air, the derating requirements may be reduced or eliminated. Additionally, if the conductors are specifically designed for high-temperature applications, they may be able to withstand higher temperatures without derating. However, it is always important to consult the NEC and the manufacturer's specifications to determine the appropriate derating requirements for a given installation. In summary, current-carrying conductors are those connected to the electrical source and the load, and they are used to carry current in a circuit. When determining the derating factor for conductors in a raceway or cable, it is important to consider the number of current carrying conductors, the ambient temperature, and the potential for harmonic currents. The NEC provides guidelines for determining when a neutral conductor should be counted as a current carrying conductor and for calculating the appropriate derating factor. For the specific scenario with 4 hot conductors and 4 neutral conductors, the derating calculation should be based on the 4 hot conductors, requiring a 20% derating factor according to Table 310.15. The E2 of the NEC. Understanding these principles ensures safe and compliant electrical installations.